Namaste, Jai Shri Ram. My name is Sujay K. I'm working as an assistant professor in the Department of Electronics and Communication Engineering at Vivekananda College of Engineering and Technology, Puttur. So, I'll be explaining about the experiment named study of truth table for the basic gates and universal gates. So, basic gates are AND, OR, and NOT gate, and the universal gates are NOR gate and NAND gate. So, before doing the circuit, we need to know the IC number for the basic gates and the universal gates. So, the IC number for the OR gate is IC7432. The IC number for AND gate is IC7408. IC number for the NOT gate is IC7404. IC number for the NAND gate is IC7400. And IC number for the NOR gate is IC7402. So we'll first verify the truth table for the OR gate. So this is the pin diagram for the OR gate. So as you know already that the IC number for the OR gate is 7432. So inside the IC7432, this would be the arrangement. So there will be 4 OR gate, and if you consider the first OR gate, pin number 1 and pin number 2 will be the inputs. Pin number 3 will be the output. So we'll do the connection for the OR gate. So for doing the connection of the and to verify the truth table of the various basic gates and universal gates, we'll use the digital IC trainer kit. So in this we have totally 6 sockets. So you can use any of the socket. And I'm going to use the first socket, and in the first socket there is a IC holder, or there is a slot, IC slot, where we are going to place the IC. Okay, so we are going for the OR gate. We are going to use the IC7432. So I'm going to place this IC into this slot, and then after placing the IC to this slot, then lock it. Next, before connecting the input and output from the pin to the from the pins to the switches and to the output, so we need to connect the pin number from pin number 14 to the +5 power supply, and then from pin number 7 connected to the ground point. So after doing this connection, 2 important connection, which is the +5 volt to the pin number 14 and pin number 7 to the ground. Next we need to connect the input. So pin number 1 will be connected to the, so here we have 2 sections here. So this particular section is input switches, where the input pin will be connected to these switches, and the upper part is the output indicators. So pin number 1 will be connected. So here we can connect it to any switches. So I'll be connecting to the first switch. So pin number 1 will be connected to the first switch, and pin number 2 will be connected to the second switch. Next, pin number 3 will be connected to the output. So after doing this connection, switch on the trainer kit, and then we will verify the truth table of the OR gate. So as you can see, so when both the inputs are 0 0, means when both the switches are off, so the output is 0. So as you can see, both the switches are off and the output is also 0. For the second case, when the first input is 0 and second input is 1, which means the first switch should be in the off position and second switch is on. So if I switch on the second switch, output is 1. So the output is 1. Next, for the third input case, the first input is 1 and the second input is 0. That means I need to switch on the first switch. So the output is 1 here. Next, for the last input case, when both are 1, the output is 1. So if I switch on both the switches, the output is 1. Next, after verifying the output with the corresponding truth table, next we'll do the connection for the AND gate. So the connection for the AND gate is same as that of an OR gate, but the only change is you need to replace the IC. So for AND gate you have to use the IC number IC7408. So place this IC in the IC holder. Yes. After placing this IC holder, the remaining connections are same, no change. Next, we'll verify the truth table for the AND gate. So switch on the trainer gate. Next, again for the first input case, where when both the inputs are 0 0, that means both the switches are off, the output is off, 0. Next, when for the second input case, where first input is 0 and second input is 1, so I'll make the second switch on. So output is off, here also the output is off. For the third input case, where the first input is 1, which means I need to make the first switch on, output is still off, which is 0. Next, when both the switches are on, that is here for the last input case, for both the inputs are 1, you have to make both the switches on, the output will be 1. So hence the truth table of AND gate is verified. Next, we'll move on for the next gate, which is AND gate. So again, connection for the AND gate is same as that of AND and OR, no change. So I'm going to place the NAND gate IC, which is IC7400. So place it on the IC holder. So after placing the IC, again, as I said, the connections for AND gate, OR gate and AND gate is same, no change. Next, we will verify the truth table. So switch on the trainer gate. So as you can see in the truth table, for the first case 0 0, the output is 1. So as you can see here, when both the switches are off, the output is on, which means logic 1. Next, for the second input case, when the first input is 0 and second input is 1, the output should be 1. So if I make the second switch on, the output is still on, which is 1. Next, for the third input case, when the first input is 1 and second input is 0, the output should be 1. So I'm going to make this first switch on. So the output is LED is glowing, which represents 1. Next, for the last input case, where both are 1, the output will be 0. So if I make both the switches on, LED is not glowing, it is off, which represents the logic 0. So now the truth table for NAND gate is verified. Next we'll do the connection for the NOT gate. So make both the switches off, switch off the trainer kit and remove the connection for this. So for the NOT gate, I'm going to use the IC number 7404. So place this IC on the slot or the IC holder. So after placing the IC, the first important section to be made is connect from pin number 14, connect it to plus 5 volt. Next, from pin number 7, connect it to the ground point. After that, observe the pin diagram of the NOT gate, where pin number 1 is the input and pin number 2 is the output. So inside the IC 7404 there are totally 6 NOT gate, but you have to do the connection only for the one. So we are going to use this first NOT gate, and for the first NOT gate the input will be from pin number 1 and output is taken from pin number 2. So take the patch cord and connect pin number 1 to the input switch, and from pin number 2 connect it to the output. So after doing the connection, we will verify the truth table. So as you can see, for the NOT gate there is only one input. So if logic 0 is applied, then we'll get the complement of input, which is 1. And if we apply 1 to the input, we'll get 0. So I'll switch on the trainer gate. So as you can see, the switch is off. So the output of the NOT gate is 1. So when A is 0, the output will be 1. Next, if I make the switch on, the output is 0. That means when A is 1, the output is 0, which represents that the output will be, the LED will be off. Next, so we have verified the truth table for NOT gate. So we'll go for the last gate, last universal gate, which is the NOR gate. Okay, so switch off the trainer gate, remove the connections. Remove the IC. Next, place the NOR gate IC. So IC number for the NOR gate is IC 7402. So place it on the IC slot or the IC holder. After that, make the two important connection, which is from pin number 14, connect it to plus 5 power supply, and then from pin number 7 connect it to the ground. From plus 5 connect it to the pin number 14. Next, from pin number 7 connect it to the ground. So as you can see in the pin diagram of IC 7402, the arrangement is different from the previous gates. So here inside the IC 7402, again totally there are 4 NOR gates. We are going to use only the first NOR gate, and for the first NOR gate, observe that pin number 1 is the output pin number 2 and 3 will be the inputs. So I'm going to connect from pin number 2, connect it to the switch. Next I'm going to connect pin number 3 to the next input switch. Last, pin number 1 will be connected to the output. So after the connection is done, let's verify the truth table for the NOR gate. So switch on the NOR gate. So as you can see from the truth table that when both the inputs are 0 and 0, the output is 1. So as you can see in the board, both the switches are off, the LED is glowing, that means which represents the logic 1. Next, for the second input case where the first input is 0, second input is 1. So I need to make the second switch on. So for the second input case, the output is 0. So as you can see here, the LED is off, which represents logic 0. For the third input case, when the first input is 1, second input is 0, the output is 0. So I'm going to change the input. So first input is 1 and the second input is 0, the output is 0. For the last input case, when both are 1, the output is 0. So I'm going to make, already the first switch is on, I'm going to make the second switch on. So when both the switches are on, the output is 0. So hence we have verified the truth table for NOR gate. Thank you.